Hey guys, welcome back. So today we're going to be doing minimum spanning trees and we're going to be looking at KRUSKAL'S algorithm specifically. In the previous video we've looked at prims, and today we're going to look at another algorithm just to be able to get us to our minimum spanning tree. Okay, so quick reminder again, what is needed for a minimum spanning tree? 1, all vertices need to be connected in the network, and 2, you can't have any cycles, so there shouldn't be any loops. Okay, now I'm just going to go through what an algorithm is again. An algorithm is just a simple set of instructions that you do one at a time to get you to your desired goal. Okay, so like a recipe for making a peanut butter and jelly sandwich, we have steps like getting 2 slices of bread, putting the peanut butter on one side, putting the jam on the other, sticking them together, and then lastly cutting it diagonally so it's nice and easy to eat. Done. So that's an example of an algorithm, so don't get too wound up about some fancy word that sounds like it's from the future. Alright, so KRUSKAL'S algorithm is a little bit different to prims, but it gets us the same result in terms of the weight, so it might look different though. Alright, so KRUSKAL'S algorithm tells us to sort the edges by ascending order, so smallest to largest. And I reckon this step's actually kind of unnecessary, but I'll show you in a second. Step 2, start with the tree consisting of the vertices of the graph, but no edges. So this is one way where you'd redraw all the vertices, and then we'd connect them together. Step 3, add the edges one at a time in order of ascending order, and you've got to make sure there's no cycles, like we mentioned before. Lastly, repeat step 3 until all vertices are connected. Okay, now that's KRUSKAL'S algorithm. I'm going to give you a slightly different take on it because I think there's a slightly easier way to implement his algorithm. So let's have a look at some examples now. Okay, so here we have a network that we want to make a minimum spanning tree out of, and we're going to use KRUSKAL'S algorithm to do it. Now KRUSKAL tells us you need to sort these edges from smallest to largest. But I think you can just do it by eye. So let's go ahead and do it. So the first step here, the smallest edge is clearly going to be 5, so I'm going to highlight that there. Now KRUSKAL'S algorithm says you find the next smallest edge within the network. So this has to be 8 just by looking at it. And then I literally just repeat that process until I have my minimum spanning tree, ensuring I have no cycles. So what's my next smallest edge? It looks like that's going to be 9. So highlight that there. The next smallest edge looks like it's going to be 10. Now once again, if you have 2 which are the same weight, so as long as it doesn't make a cycle, just do them both simultaneously. So do them both at the same time. 10 and then there. And then lastly, looks like we're done. So all the vertices are connected. So if you would like to draw this out separately, it should look like this. Done. Okay, let's look at the next example. Okay, so once again, KRUSKAL tells us to start with the smallest edge. So just by looking at it, I think it's going to be 4 there. Okay, cool. What's the next smallest edge? Looks like it is going to be 5. So I'm going to highlight that there. What's the next smallest one? It looks like it's going to be 6. And then lastly, I need the next one, which is 8. Now notice, you could be easily tricked to think that that's it. But if you have a close look, it's not connected, is it? So you need to ensure that your minimum spanning tree is connected. So it looks like our next smallest edge will be 9 and 9. And so as long as it doesn't cause a loop, you need to highlight both. So here, oh my bad, doing both 9s would cause a loop, because if I do this 9 as well, that's going to make a loop here. So in this case, we'll only choose 1. So let's say that is our minimum spanning tree using Kruskal's algorithm. Alright, cool, let's do one more. Okay, so once again, start with smallest edge. So just by inspecting, I think it's 9. Continue to the next smallest one, that will be 10. The next smallest one after 10, it looks like it's going to be 12 here. The next smallest one after that, I think it's going to be 14. And then that is it. So all your vertices connected, yes, 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 yes. So our minimum spanning tree looks like this. (14, 12, 9, and 10). And obviously if you wanted to find the weight, you would add all these up. So 14 plus 12 plus 9 plus 10. Alright, cool. So if you have any questions, leave them down in the comments below. This is how to use Kruskal's algorithm. Usually you get a choice of using Kruskal's or Prim's, but sometimes your teachers are sneaky and will ask you to use a specific technique or a specific algorithm, because remember, they don't always look the same. Okay, cool. Thanks guys. I'll see you in the next one.